we are going to deal about module 5 of unit 1. So all these classes we had very detailed discussion about various searching algorithms, right? Uninformed searches, informed searches, and the various environments of AI, those things and all we discussed. Do you remember all that? So we heard even the term called the heuristic function, which is very new to you, right? So what are all the algorithms we discussed under uninformed searching algorithm? BFS, UCS. A star comes under informed search. So under informed searching, what are all the algorithms we discussed? Greedy, best first search algorithm, A star algorithm, SMA means simplified memory bounded A star algorithm. So those things we cannot forget all those things because those concepts will be utilized even in future concepts. Okay, fine. So the algorithm what we discussed earlier all about dealing the single agent. Okay, so we discussed even various environments. Do you remember that? Various environments of AI. Fully observable, partially observable, deterministic, non-deterministic or stochastic, static, dynamic. Finally, as a last environment type, we discussed about single agent and multi-agent. When we say single agent, in the space, in the search space, there will be only one agent, like your vacuum cleaner or autonomous car, or it may be of any gaming. Whatever we discussed as an example where one will be the AI, other one will be the human, which means only one agent was playing a role. Whereas when you take the example as football, okay, or some other games where both of them could be a AI, whenever you consider both the players or more than one players as computer or artificial intelligence, we say that it is a multi-agent environment. In an environment or in a search space, in a game space, if more than one players are playing and both the players are assumed as a AI or computer, we say that multi-environment search space. Okay, so all the algorithms what we were dealing about only to find a solution in the single agent environment. Okay, but that cannot be as it is used for the multi-agent environment, and that is where we go with another concept called adversarial searches. So it is mainly applicable for the multi-agent environment. What do you mean by multi-agent environment? In a search space or in a space where AI is going to play a role, there will be more than one agent or there will be more than one AI, there will be more than one role of the computer, which we call it as multi-agent environment. So whenever we consider a multi-agent environment, like any game, this is applicable mainly for the gaming theory or any AI-powered game you are developing, we go with adversarial search. Okay. So now what is the adversarial search? It is searches in which two or more players with conflicting goals, which means it must be a competitive goals, like both are going on the same pace, like there is no competition or just going along means there also we don't go with the adversarial searches. When there is a competition, like one is trying to win, one is trying to make other one to lose. When there is always it is like that, right? When you are playing a chess, one player always try to win and he will try to other one to lose. That will be the intention behind any competition. So whenever there is a conflicting goals, each one is trying to win in the game. Each one is trying to make other one to lose the game, where we go with the adversarial search. So here the game is modeled with search problem as well as heuristic evaluation function. So search, what kind of search we are going to apply and how do we calculate the heuristic evaluation function. So using these two things only we will be able to model the game. Yeah. So you need to know few more things about the game. There are various types of game, deterministic and non-deterministic or stochastic. Okay. What do you mean by deterministic? For each move I will be able to know what will be the next step. Okay. So if I move this coin, this will be the result. So I can determine the result of each and every action. That we call it as deterministic. Non-deterministic means I will not be able to, like when you are playing a card game. Okay, so you will not be able to determine. You leave one card, what your opponent will be releasing a card, you cannot get any idea. Okay, so definitely if it is in the case of chess, for your move, definitely the opponent will give one sensible, intelligent move. So poker, you cannot predict what will be the next card will be thrown out by your opponent. Whereas here it is not like that. And for each and every of your action, what is the next state or what is the resulting state will be determined in deterministic, whereas it cannot be determined in non-deterministic. And again, that is commonly classified as perfect information and imperfect information. Like for a particular game, you will be able to clearly say this is what the instruction, this is what the instruction you need to follow. But for certain game, you cannot follow certain instructions. Again, you can take chess itself, you have certain instructions which you cannot violate. Whereas when you are playing cards, there is no such instruction. Correct? There is no such instruction. To play, for the result there will be something, rule. But to play, there is no instruction in the card game. So what you need to understand here is perfect information means for the game, the informations will be clearly defined, which we call it as perfect information. When we are not able to define the instructions, we say it is an imperfect information. These things are used when you are designing a game. When you are developing a AI-powered game, these informations will be considered. Okay. A game can be defined using, these are all the basic elements to design any game. Initial state, number of players, what action can be performed, what should be the expected result, and what is the terminal test, and additionally utility or payoff function. So always when you start playing a game, like when you are playing badminton, this is where you have to stand. This is you have to hold your racket, like many rules are there. Okay. So when you are starting a game, what is the initial state? What is the initial position irrespective of any game? Next, players. Number of players. Who are all the players? Who are all will be on one side? Who are all will be on the other side? How many players are going to play in a game? So that is needed to design any game. Action. What are all the actions can be performed? Again, if it is chess, a different action is taken place. Tic-tac-toe. Have you ever played this? We are going to see that. Okay. We used to call that as XO game. Right? X and O are used to play game. So there we have certain number of players. So depending upon the game, the number of players varies, the actions varies, and the result also varies. Okay. Terminal state. When you reach a particular state, we can announce the result. Either one person may win, other person may lose, or the game may be ended up with draw. Right? So if both of them are not able to win, it may be closed with draw state. So what is the terminal state and utility? So we will be using some values. Okay. Sometimes in a game, if even both are reached at the same time, the time will play a very important role. Within what time this particular person is reached, within what time other person is completed the game. We are saying so many games, and that is being announced the winning state depending upon the timing. Okay. So there we will be using some value. Some games will be announced or will be declared the result based on the some value. That may be a time or the score, it may be of anything. Okay. So that is utility or a payoff function. So these are the elements we use when we define any game. Clear this? Yes. Yeah. So here is the game tree. Always we will structure our gaming using a tree. Game tree. And this game tree is for tic-tac-toe game. So before that we will just see what is tic-tac-toe. Somebody is going to play the game here. This will be the initial state. As I mentioned, for any game there must be an initial state. And for this game there will be two players. Okay, two players. Always we start with X O. Correct? So X can be. So how do you play this game? So anybody can play X or O anywhere. Like first player will be placing X somewhere, and the next player will be placing O somewhere. So somewhere along we will be placing our X or O. Finally, how do you declare the result? What will be the winning criteria here? Still the same row you must get, or it must be in the same column, or if anybody is getting all the three in the same diagonal is announced as winner. It is possible even for O. Irrespective of it is O or X, all the three, the consecutive three in a row or in a column or in the diagonal, if you are getting all the three as same, like your symbol, then we say that that particular player is won the game. Clear? Right? So this is how we play tic-tac-toe. We are going to take one, here we need to know even heuristic evaluation. I'll just explain you, then we'll move on to that. Heuristic evaluation function. We'll take one initial state, or I'm taking some state from where I'm going to start my game. Yeah, this is the state, because when you start from the beginning, if you look at this, so max of, as I mentioned, X will start again. So initially it is all empty. We are naming the players as max and min. Max and min. Okay. So if the game starts with X, so X is, max is getting a chance to play X on all the 9 tiles, because it is a 3x3 grid. Okay. Since it is a 3x3 grid, first player is getting chance to play his X on all the 9 tiles. Okay. Whereas when you consider the second, that is next turn is for O. Alternatively they will be playing. Each one will be getting one chance at a time. So when the first possibility is taken, he has opportunity to place his O. How many chances are there? How many tiles are open for him to place O? 8. Similarly, for the second play also, other 8. Anyway, he will be getting 8 opportunity on a different tiles. So it goes on. We are not going to see the entire thing. Okay. See again, to place X for max 2 is already filled. From the remaining 7, we will be getting the opportunity. Like that, we will be proceeding. When the game will get over, if any one of them are having either X on all the 3 lines, either row wise or column wise or diagonal wise, so X won the game. Similarly, if O could place O on a consecutive 3 cells in a row wise or a column wise or diagonal wise, we can say that O won the game. Okay, so this is about this game. Okay, so in this, the very important thing is utility function. Utility function. Okay, so when we are taking a game tree, normally utility value will be decided by the designer. Okay, so that is what I will be explaining here, how the heuristic evaluation function is applied over here to get the utility value. But before that, I will just explain you the formula. If it is a terminal, that is when you come to the leaf node, to the last level we reach, you have only one opportunity, only one cell to place your either X or O, or the game got over still before itself. Whatever it may be, since it is a tree, you will reach to the leaf node. Correct? Whenever we say tree, you start from the root till the leaf, you will be traveling. Correct? No? So finally the trees ended up with a leaf node. So if it is the leaf node, there we will be assigning the utility value. Utility value. With respect to this, if O is going to win, we say we give the value as -1. If it is going to ended up with the draw, the value is assigned as 0. If X is going to win, they give the value as +1. With respect to tic-tac-toe, the same thing can be even taken as -infinity, 0 or +infinity. Okay, so it could be -1, 0 plus 1 or minus infinity 0 plus infinity. So the utility value either this way we can take or we can assign the value for all leaf node. Okay. From there we will be doing the backward way. Backtracking we will be doing from the end to you will go back and you will be assigning the value on each and every level. Like that you will reach the root node. So root node whatever the value is getting, it is getting some value that is nothing but that many possibilities are there for my max or men to win the game. Okay, I am saying some utility value we are assigning. We are going to backtrack. We will reach to the root node. What is the use of it? Whatever you have made it as a root, it may be either max or min. With both the variations, I will explain with an example. Okay, so for max to win the game or to min to win the game, we are finding out the possible values. Possible values. Okay, so that possible values could be calculated only from the utility value. So utility value is given for the leaf node. By applying the utility function, we get the value for the root node and we will be finding out even the optimal path. Okay, so yeah, we will see here now. So this is the thing I have taken at some particular time. This is the state of my game. Okay, so already yeah, 3 times X has played and 3 times O also has played. Okay, so now which player is going to place its symbol? X. It is the turn for X. How many chances are there for X here? Yes? Okay, how many possibilities for X to win the game? So we are going to calculate the heuristic value. How many possibilities to win the game for X? Look at this. Only one. 1 or 2? See, this way it can win. Or next if it gets X. So there are, at this scenario, there are 2 possibilities for X to win the game. You have to see all the possibilities. Okay, so no more possibilities. I cannot put over here. So with this scenario, I can keep X over here or here. First time I am keeping X. Next time suppose O misses the chance. Again I will give a chance for X to place X over here. So maximum 2 possibilities for X to win the game. 2 minus, always the formula to calculate heuristic value or heuristic function is X to win the game minus O to win the game. X to win the game because X is considered as max, O is considered as min. Please remember because we are going to start the game with X only followed by O. So always the formula used to calculate heuristic function is X to win the possibility minus O to win the possibility. Now tell me from this, how many possibilities are there for O to win the game? Only one? 2 or? Tell me how? This is one possibility. What other possibility is there? Only one possibility. So 2 minus 1 is equal to 1. Only one possibility is there. புரியுதா இது என்னன்னு? Yes. வேற என்ன போடலாம் சொல்லுங்க? Where you will place 2O? This is already filled. Second time if you put O also, where will you put? Yeah. Yes. புரியுதா? X போட்டதுக்கு அப்புறம் இல்லமா, this is the state I have taken. With this I am checking when I am giving a chance for X, the winning possibility is 2. For O, the winning possibility is only 1. Wherever you put O, just check. Is there any possibility for O to win? There is only one possibility. For this initial state, I am checking the heuristic value as, I am getting the value as only 1. Clear this? Yes? So now I am going to move on to the next level. This is how we need to calculate it. I am just showing you how heuristic value is getting calculated. It's clear? Possibility for X to win minus possibility for O to win. As simple as that. Okay? Right. So now we are going to apply the logic of what ma'am taught for 8 puzzle. You remember 8 puzzle solving. Okay, so there we were calculating the heuristic value. How to calculate heuristic value? The formula only varies here. Okay, so here there are 3 places. Wherever first I am going to place x. For placing x. For placing x, there are 3 possibilities. I can place x over here, or x over here. Right? So all the 3 you need to write. See, the turn will get changed alternatively. So now it is the turn for x. So to place x for me, I am having 3 possibilities. Try all the 3. This is the previous level. You can do along with me. So what are all the 3 possibilities? I can place my x over here. I can place my x over here. Suppose I am placing my x over here. Now you need to check the heuristic value. So heuristic value in future could be the next. If I am getting x over here, okay, I will not get any winning possibility. So here x and here x means I have 2 possibilities. So again, heuristic value calculation could be 2 minus. So even if you place O on both the cells also, will you be getting the chance for O to win? You won't get it. So it will be 0. So at this level, heuristic value is 2. I repeat again. Here I have taken the first possibility of placing my x over here. Right? Because I have 3 possibilities. I am going to place x over here, and in this case I will be placing x over here, and in this case I am going to place x over here. All the 3 I have tried. So for all the 3 I am calculating my heuristic value. So here possibility for x to win is 2. Possibility for O to win is 0. After I place x over here. So my heuristic value is 2. Right. So now I have placed my x here. Now again, possibility for x to win is 2. Possibility for O to win is 0. 0. Okay. Okay. So 0. So here, possibility for O to win is irundhalum. Already it is in the winning state. I have got all the x in the same row. Already the state is 1. Clear this? So, I don't have to see the heuristic value over here. It is the winning state. I repeat again. There are 3 possibilities for x to be placed. So one could be here, one could be here, one could be here. By saying this itself, I can say it is already won the game. So for the other things, I am calculating the heuristic value. So whichever heuristic value is less, I will be proceeding. Okay. So here if you see, the possibility for the x to win is 2. X to win is 2. But for the O to win is nothing. There is no possibility at all. Is there any condition for fraud to happen over here? Because the next turn is given for O. So if O is going to be placed, whether x will win the game, that thing also we have to check. Just by seeing it, you may say that for x it is 2 chances, but for O there is no chance at all. But you have to see that the next turn is going to be given for O. So when O is going to play O over here, it will become draw. Okay. So this also we will not be considering. So we are going to proceed only with this. We are going to proceed only with this. So like that you reach till the end, till you get only one block in that, or already if you can reach when we can just close it with this itself, because x is 1. You are able to follow this. So what you are learning here, how we are proceeding the game and how we are calculating the heuristic value with this example. But actually how the game tree will be designed always max to win or min to win. Max to win or min to win. X to win or O to win. With that only we will be designing the game tree, because one player is AI, other player is also AI. Both of them will be playing in a competitive spirit. Okay, so this will be trying to make other one to lose, other one will be trying to make this one to lose. So your perception is whether max to win or min to win. Okay, so for both we will be seeing one example. Yeah, I'll explain this, then manually one I will show you. Okay. So as I mentioned, we will be doing a backtracking. So here we are going to try max to win, as the T starts with max. Whichever player you want to make to win, he will be made as a root. Clear, Danush? So whoever wants to win, you have to make them as max, and that will be root. Okay, so here max is a root. Alternatively, the players will be playing. So max, after that max, and when it comes to the leaf node, I'm going to close my game tree with this itself. But if it is a complicated game, it will go infinitely. So many steps will be there. Okay, fine. So yeah, for all the leaf node, I have given the utility value as 4362. Calculation of this utility value again varies depending upon what game you are developing. So if it is tic-tac-toe, this way we will be calculating the heuristic value, or the designer may assign some value. We have seen assigning a heuristic value on various algorithms, A*, Go, greedy, best first search. We have assigned some heuristic value. Okay, so it can be of either way. Here we are taking utility value for all the leaf node in this manner. This is my initial state. Okay, so we are going to do two things. One is, what is the value for max? When I find the value for max, what is the meaning of it? Yes? Solena, what for we are finding out the value for max or min, whoever is there in the root? Huh? Finding out the possibility for the root to win the game. Okay, how many possibilities are there for my max to win or min to win? Whoever is there in the root, right? So that we will be finding out. Once we find out that, we will find the optimal path. Which way if it goes, it will win the game. So here, if it goes on this manner, it will be able to win the game. Suppose by mistake I am not choosing this, I am choosing this, and it will be going for 2 or 3 more steps. This you would have realized when we are playing a game. இதுக்கு பதிலா நம்ம இங்க போட்டுட்டோம்னா we could have won the game. அப்படி ஒரு இது வருது இல்லையா? So since I chosen other path, I will have to move one more step. Which path is very optimal to win the game? That also will be found out from this. Tell this it's clear? Yes? So game tree needs to be established. Game tree needs to be established, and we will be doing the depth first search to reach the leaf node. We don't go for DFS here. We will only apply DFS to reach the leaf node. And here I am having the utility value. From then I will be doing some backup process. I will be doing backtracking, backup the value till I reach the root. So root once I reach, I will get the value of root, which means possibility to win the game. Once I could reach that, then I can find all the path. From that I can choose the optimal path to win the game. Clear? Yeah, this is the initial state of my game tree. You will just go down if you require. Are you copying or copied already? Shall we proceed, Kamalesh? Yes? Copy first. So, with respect to this, few points you need to remember. First, we need to generate a main tree, which you are seeing it on the screen. Next, we need to apply utility value, that is also given over there. Utility value only for the leaf nodes are given. We need to get for the root node. Then we will be using DFS to reach leaf, and then we will be doing the backup values for the root, and finally find the optimal path. So these are all the 5 things we will be doing whenever we design any game. It's clear? Shall we proceed? Copied everybody? Kindly respond.
Yes, ma'am.
Okay. Ma'am. Yeah. See here, we need to do depth first search. How do we do depth first search? Always, John Paul, when we are applying depth first search, which way we will be traversing?
Left side.
Left side. So we need to traverse on the left tree first. So you are coming to this node, and then finally this node. So there you find the value 4. You find the value 4. Okay. So max now always we need to find maximum amount 2 values. Okay. Minimum you will be finding the minimum amount 2 values. So at this point there is no 2 value, only 4. This 4 will be moved into its parent. 4 will be moved into its parent. Okay, and then you have come to root. So you have to visit the right chain of this particular subtree. There you are finding value 3. So this 3 also will be brought over here. Make a comparison among 4 and 3. So 4 is bigger. 4 is bigger. This you are doing it for max. Max now always you have to take the maximum amount 2 values. So here it will be assigned as 4. 4. Right? So what are all the things we have done? We have done the depth first search of that subtree, and we have got the value for its root or its parent. We have backed up 4 to this root. Okay. So next is there is no more child over there. We need to go to parent again, to its own parent. So there you need to go towards right because it has given the right subtree. You will come. You don't have any value because only the leaf you have the value. Again, when you search, you are coming over here. 6. Okay. So 6 will be back to its root, and then you come back to the right side to compare both of them. 6 will be back over here. Here 6 will be assigned. Now tell me, here you have 4, here you have 6. What will be the value taken for min? 4. Because minimum of these two only will be assigned to its parent. That is 4 and 6. Okay. Now next, minimum of that will be 4. Clear up to this? Now what is our next job? Left the subtree of this, one subtree is over. So we need to go to its main root. Okay. 4 only will be moved into root also. No. Yes. Yeah, 4 will, no, read this one. No. Yeah, 4 only will be assigned over there. Okay. So then you have to take this subtree, left first search. So you will take the left subtree, leftmost you will be coming. Here you have 2 will be assigned over here, and then you come back here, 1 maximum of max, once you find the value for the main root, you have to see the same value wherever is placed, in whichever root it is placed, that is considered as the optimal path. So here 5 is the root and here this is the path. Everywhere we are having 5 and that path is considered as optimal path. It's clear? Shall we take one more example? Yes? This I am taking it as max. To differentiate I am giving this as circle and this as dot again. Any doubt you can ask me. This problem you are going to solve on your own. Information provided here. You have 3 levels. Okay. So max, min, max, and here is your leaf node. So leaf node is given a utility value. Now what are all the things we need to do? What we are supposed to do? What is the objective of this? Finding out the maximum value because max is my root. இதே மாதிரி I can make min also to win. அப்போ நான் min வந்து root ஆ கொடுத்து other things is coming after that now I am trying to find out the optimal path for min to win. But here the problem is max to win. What are all the things I need to do now? I need to find the value for max and then I need to find the optimal path. Will you be able to solve this? Kindly do it, make it fast. 10 now. Note the workout பண்ணாமே பார்த்து சொல்றீங்களா? Okay, fine. Max value will be 10. Max value will be 10. What will be the optimal path? Which is the optimal path? Yes, this leftmost will be the optimal path. Anybody will be able to guide me to solve this? Yes. So here you are coming towards this leftmost node. So using the DFS, so this is considered. So when I go root timing, I am assigning this 10 value over here, and this has the right subtree. So I will come here, and this value will be back over there. 10 and 9 both are compared since it is maximum. So which value is assigned? 10. Okay. So with this I cannot stop, and this will be back over there. 10. So I have to come this way till I reach this node. 14, okay, so 14 will be back, 9 will here, then I need to traverse on this side, it is 18, when you compare both of them, 18 is greater, so 18 will be assigned, correct? So then here already I have 10 and this is 18, it is min, so minimum value is assigned 10, okay? So this with this 10 I will be waiting over here, then I need to go traverse on the right subtree. Okay, so I come here, 5. So 5 will be back and right side I am sitting, it is 4. So 5 and 4 which is maximum, it is 5. So with the 5 I will be assigning here. So I go on this way, this is 50. So here it is 50, with 50 only I am waiting. I traverse on the right side, maximum is 50. So 50 is assigned. Okay, so here I have 5 and here I have 50 which is minimum 5. So here I will be assigning 5. Okay, so here it is 10 and here it is 5. Since it is maximum, I need to consider only maximum. So my max is equal to 10. Clear? So where I have 10, only in this path. So this is considered as optimal path, which means this is the path I should follow for my max to win the game. Okay, the player who is going to draw X in my grid will win the possibility only if it follows this path. Clear this? Next. Now this is your pseudocode of plan. This will be explained in the afternoon session. Okay. And next. Yeah. So the properties But again, there is a constraint for all the complex problems. We cannot expect this algorithm to provide a optimal path. Okay, and that is where another algorithm comes to existence, which is called alpha beta pruning algorithm. There are some limitations there, whatever I explained you can see. The main drawback is that it gets really slow for complex games such as chess, go, etc. Because chess game and all, if you take it, go hours together, even days together it will go, right? So for that, the optimal path finding should be designed properly, right? So there, this cannot be a perfect algorithm. This type of games has a huge branching factor. So many branching will be there. This is at least only 9, but when you consider a big board game like chess, so many branching will be there. And obviously, space complexity and time complexity will be increased due to that. So this is not very good for all type of gaming. This limitation of the game is overcome by alpha beta pruning algorithm. Ma'am will take over for this. Thank you.
Apa sir?